We are live. We're doing it live, just like Bill O'Reilly. All right, so one of the things we're going to talk about, chapter 2.4, is average rate of change. Okay? Now, one of the things that I love about this is they give you all this math notation to make it look really hard, okay? When you hear average rate of change, I want you to think slope. That's exactly what it is, okay? Now, you guys remember the slope function, right? What's the slope formula? What is it?
y2 minus y1 over x2.
Equals y2 minus y1 over x2 minus x1. Okay? And honestly, I don't care whether you have the 1 first or the 2 first, it doesn't really matter. But anyway, okay? Now, if I change that to have functional notation for the y, in fact, instead of using 1s and 2s, I'm going to use an a and a b. How about that? I'm going to change this to a and b. I'm going to change this to a and b. Okay? Haven't really done anything different except change the letters, right? Okay? Now, the average rate of change is f of a minus f of b divided by a minus b. Now, I think they did it backwards in the book, but like I said, it doesn't really matter. Okay? If I change this to B and A, I'm going to change this to B and A. I change this to B and A. I change this to B and A. Have I really done anything? Okay. Now, what they want to do is they want you to see this, and they want you to freak out. Okay? But I'm telling you, there's no reason to freak out. Okay, it's just the same thing as the slope formula. All it is the slope formula. Okay, that's all we're doing. Okay, all we're doing is we're doing this, and then we're gonna throw this at you, and you're gonna be like, ah, that's got a bunch of letters in it. I don't like it, but it's the slope formula. That's all it is. Okay, so let's do an example here. Let's say that f of x equals x minus 3 squared. And I say find the average rate of change between x equals 1 and x equals 3, okay? But rather, oh, no, that's fine. Okay. So, do I still have this here? I don't know. I'm just gonna. I gotta start learning people's names a little better. I know you don't. Okay. How about? I already know Marco's name. I know Gunner's name. I don't know. Is it Victor? Oh, good. I got Victor's name today. Victor's like, dang it. Okay, can you tell me the average rate of change for this function between 1 and 3?
I mean, you just plug in 1 and 3.
Yep, that's all you do. Okay, so what's f of 1?
4.
Okay, you're going too fast for me. How do I figure that out?
1 minus 3.
1 minus 3 squared is negative 2 squared is
4.
4. Okay, what's f of 3?
0.
Slow down, would you?
3 minus 3 is 0.
3 minus 3 squared is 0. Okay? Okay? All right, so essentially what I've done is I've found the numerator. Now, which one do you want to call A and which one do you want to call B? I don't care.
Just call 1 A and 3 B.
A and B, right? Okay? So we're going to use this formula. F of B is 0 minus, what's f of a? 4 over, what's b?
3.
3 minus 1 equals
Negative 4 over 2. So negative 1/2.
negative 1/2,
Negative 2.
negative 2. Okay? All right, Victor's got this down. Okay? All right, how about I'll just ask for the net change. What is the net change? Should have picked on Marco. Okay, tell me your name.
Jackson.
Jackson.
Net change?
Yeah. Between 1 and 3.
So you just plug in negative 2?
No, we've actually already done most of the work.
So what is that?
So the net change between 1 and 3 is just basically 4 minus 0. That's your net change.
So that's it?
So they're saying, let me make sure I got that right.
It's just the numerator?
Yeah, it's just the numerator. Oh, except for they went negative, whatever. Negative 4, positive 4, I don't really care. It's 4 minus 0, it's a net change.
So net change.
I don't think I'm gonna ask you that. I'm gonna ask you for the average rate of change. That's what I'm more concerned about. Okay? What about between, average rate of change between 7 and 3? Let's pick on, tell me your name. Steven.
Yes.
Same equation.
Same equation here, yes, same function. How would you do that?
It's the same problem.
Same function.
Just start plugging it in.
Okay, tell me what to plug in.
You just multiply them together, right?
Multiply what together?
Times x minus 3.
I want to do the same thing, between 1 and 3. So last time I found f of 1 and f of 3, what do I want to do now?
7.
F of 7 and f of 3. Well, we've already done 3, right? That's 0, because we already did that one. What's f of 7?
Yeah, the 7 would be then just 7 minus 7 minus you multiply the 7 into 3.
Oh, you stick the 7 in here,
Yeah,
Subtract
7 minus 3.
3.
Is 8.
and squared. So 7 minus 3 is what? 4, and squared is what?
16.
16. Okay, so the average rate of change between 7 and 3 is what? I heard the answer, but I want Steven to answer it.
16.
16 minus 0, right? So you're saying this is your B and this is your A, right? So 16 minus 0 over what's B?
B is 8.
7 minus 3.
Yes.
Are you sure you know what you're doing?
No, I'm not.
Okay. I'm trying to help you to know. Okay, does this make sense? This is your average rate of change. Think of it as just the slope. Okay, so you're using this formula. So I found your f of b minus your f of a over b minus a. That's exactly what I'm doing. Okay? Are you gonna ace my quiz tomorrow?
I'm gonna ace it.
Okay, you better. Okay, so I'm gonna get 16 over 4, which equals
4.
Okay, your average rate of change from 7 to 3 is 4. Okay, also your slope. Is it Bailey?
Yes.
All right, another name.
Um,
You're in trouble now.
no, so just a quick question. So how do we know which one is B, which one's A? Because I think
Well, how do you know which one is B and which one is A? And I say it doesn't matter. That's why I assigned 7 to B and 3 to A. But you could have assigned 7 to A and the other one to B and it wouldn't matter. So just pick, but don't change it after you pick.
Okay.
Okay?
Is there a symbol or way to write out like average rate of change? Or is it always going to be written out average rate of change? Like it works.
In this book, I don't think they use any symbols. In calculus, sometimes they'll use, it looks like a triangle, but it's the Greek letter delta. Okay? All right, well, let's do another one. Okay, I'm going to erase this, except for I'm going to keep the slope here. Okay, and oh, by the way, I can't remember if I mentioned this, so I'm going to mention it now for all those people that left. Okay, tomorrow's quiz, based on section 2.4, is going to be based on all that extra homework. So you're going to have a lot more homework from now on. Okay, so make sure you're doing the 6th edition homework. It's basically the same, and it's going to be a lot more because I want you guys to pass the test. And you're not going to pass it if you're only doing 5 problems a night. Oh, ain't no way. Okay? Most of you. Some of you, if you've had calculus, and I know some of you have, this will be an easy class for you. Some of you really need a lot of practice. Okay? So please do as much homework as you can. All right. So let's say an object is dropped from a building and it follows d of t equals 16t squared. Okay? Find the average rate of change between 1 second and 5 seconds. Okay? So, whose turn is it now? It must be, what's your name in the back? What is it? Ethan. Okay? Ethan, what do you think? I've still left your formula here so you can look at it. Plug it in. You want this one to be A and B? Okay. It really doesn't matter. You could flip those around. It wouldn't make any difference. Okay? So what's D of 1? 16 times 1 squared equals 16. What's D of 5? 16 times 25, and as everybody knows, 4 times 25 is 100. 100 times 4 is 400, okay? Check my math, but I'm pretty sure that's right. Who needs a calculator? Okay? And so therefore, how do I find my average rate of change? So we're calling this B, right? So if you said it, I didn't hear it. 400 minus 16 over 5 minus 1. I got 4 on the bottom. On the top, I've got 384. 4 times 9 is 36. 24, 696. Okay? All right. You feeling good about this? Okay. How about, oh, here's a good one. This will throw you guys for a loop. Okay? We'll keep that formula there. Between t equals a and t equals a plus h. Let's Should ask for volunteers. I bet nobody's gonna volunteer for that one. What have I picked on? Should pick on our Harvard shirt because that looks really smart. I'm gonna pick on the guy next to him. Your name is? Cameron. Cameron. Tell me your name is Jackson? What's your name?
Me?
Yeah.
Nate.
Nate's like,
Yeah,
ooh,
close. Real close.
this is saved me on that one, okay? So Cameron, what do you think? I think we're gonna call this A, what do you think?
Yeah.
Let's call that B. Okay, so we need to find f of B and f of B of A plus H, sorry. So tell me what f of
Isn't it DL?
F of A, whatever, D, I don't care. Use D, I don't care. D of A and D of A plus H. What's D of A if this is your function?
Oh, okay. Yeah, so it'd be 16 times A squared.
Okay? What's D of A plus H?
So that would be 16 times A plus H squared.
Okay? Something tells me I'm gonna have to FOIL that out. Okay? So this becomes
A plus H times A plus H, basically. And then
16 times A plus H times A plus H equals 16 times A squared
AH,
2AH.
or plus AH.
2A.
2AH plus H squared, and then if I distribute my 16, I'm gonna get
So 16A squared plus
16 times 2 is 32AH plus
16H squared.
16H squared, okay? All right, so now let's start plugging it into here. We're calling that A and we're gonna call this B, right? So this is, if that's B, what, then what do we get? We're gonna get all this first, right? We're gonna get all this, right? Okay. We're gonna get all this. Are you with me or are you lost?
No, I'm lost, sorry. We can just barely see the board
Yeah.
back here because
Does
of
it
the
help?
color and the light.
You're not gonna be able to see the video. Maybe I'll use a different color. Does that help?
Comfortable, yeah.
Blue, okay. Sorry.
And that's all over, so that would be over.
So this is D of A plus H equals that, okay? So we're gonna stick this, or rather this, right there,
Right.
okay? So then I'm gonna get what?
So that would be,
32AH.
yeah, that's
16 squared.
We're just, let me just write, so F of B is this whole thing.
Yeah.
So 16A squared plus 32AH plus 16H squared, right? And then we're gonna subtract off F of A, or D of A, which is
16 squared, so that's why I just.
16A squared. Okay? And we're gonna divide that by, what's B in this case? B is what? B is A plus H minus A. Okay, so this 16A squared is gonna knock out that A, 16A squared. This A is gonna knock out that A, and I'm gonna be left with 32AH plus 16H squared, all divided by H.
You factor out the top.
Yeah.
Oh, that's a great idea, okay? If we factor out an H out the top, we're left with 32A plus 16H divided by H. Boom, boom. I'm left with 32A plus 16H. Okay? That was easy. I'll just put 10 of those on the test, how about that? Okay?
There's a test this week too, right?
Test is on Wednesday, day after tomorrow. Okay?
In class?
In class.
Was it?
How long do we have?
We'll see how many people leave early on Wednesday. You guys will be like, no, I love this test so much, I don't want to stop. Okay? All right, that was a good one. All right, so let's do this again. I'm going to keep the formula there. All right, now we're going to do this without a formula though, okay? So let's say that I have the time. I've got 8 a.m., 9 a.m., 10 a.m., 11 a.m., noon, 1 p.m., 2 p.m., 3 p.m. Hopefully that's enough. I'll draw more if I have to. And then we've got temperature. So 38, 40, 44, 50, 56. I need to make sure my lines line up here. 62, 66, and 67, okay? So if I say find the average rate of change between 8 a.m. to 9 a.m. Okay. Whose turn is it now? It must be, I want to say Mallory. No?
No, Mallory's.
Mallory was there. She's old man.
Yeah, I'm Caitlin.
Picking on her before she leaves. Caitlin. Okay, so what would be the average rate of change for this?
Average rate of change is.
So think of this as your X's and your Y's, right?
Okay.
Or your A's and your B's, I don't care.
So you would just plug it into the equation, right?
Right, plug it into this equation.
Okay. So then you do, can you just pick any from the chart or?
No, you gotta pick between 8 and 9 a.m. So we're looking mainly at these two, right?
Yeah, okay. So then you're gonna do 40 minus 38.
So, okay, 40 minus 38 over
9 minus 8.
9 minus 8. So 40 minus 38 is?
It's 2.
2, 9 minus 8
1.
equals 2. Now, it was Bailey, I think, that asked, how do you know which is which? And I said, it doesn't matter.
As long as you keep it together.
Right. So what if we did this backwards? Let me show you why, Bailey. In fact, Bailey, can you help me figure out why? We're going to do it backwards. We're going to do everything backwards.
Okay.
Okay, and we're going to get
So we do 38 minus 40.
38 minus 40 over
8 minus 9.
8 minus 9. 38 minus 40 is
Negative 2.
negative 2. 8 minus 9, negative 1,
So it's just 2.
which is 2. See, I told you it didn't matter. Just proved it. Okay? Yes.
So in order to determine which is X and Y, or I guess in this case A and B, is it just set on like how the question is worded? So if it's changed between A and
Yeah, this isn't really A and B, is it? This is X and Y, and that's A and B, or B and A.
Okay.
I didn't do that right.
So how do you determine X and Y? Because I can see like if somebody has a preference on time being on the X-axis versus the Y-axis, then it could literally be inverse, wouldn't it?
Right.
So should we determine it based on, like, just looking at these ones, 1 and 5? I mean, they're all X
So-
values, right?
This is a question that comes up often in my statistics classes. How do you pick? And so usually we refer to the X variable as the independent variable and Y as the dependent variable. So does the temperature depend on the time, or does the time depend on the temperature? Temperature depends on the time, okay? Temperature, it depends on the time. Temperature should be the Y-axis then. Okay? Because it's not like, hey, it's 56 degrees out there, it must be noon, right? It doesn't work that way. Okay? All right. Well, that's all I got for 2.4. Okay? So we're gonna move on to 2.5. No, we're not. We're gonna skip 2.5. We're gonna move on to 2.6.
I have a question.
Yes.
Sorry. How did you determine the 40 and 38 to be the f of b and f of a instead of just the b and a for the
Okay.
formula?
So remember y can be a function of x. So this is your x variable. If your x variable is 8 and 9, and this is f of 8 and 9.
Okay. That makes
Okay,
sense.
so or your y variable.
Okay.
Okay, and like I showed Bailey, it doesn't matter the order because one of them you're going to get negatives and they're going to cancel each other. So you got positives that cancel each other, so it doesn't matter. Okay. All right. So, all right. This is a good section. I almost think we should have taught this section before we taught you. This is section 2.6. And I think it was the first day of class, or was it the second day of class when I said you should know all these graphs?
I think that was every day of class.
Yeah. Do you remember when I had a big board full of graphs you should know, y equals x squared, y equals x cubed, all that stuff?
That was the first day.
Yeah, I thought that was the first day. Okay, so section 2.6 is going to be transformations of functions. Okay? Okay, so the idea here is, first of all, what I think I'd like to do, if I had if I had f of x equals x squared, and I had, this is where I do want to use multiple colors, f of x equals x squared plus 3, okay? And I told you I wanted you to graph both functions on there. Hopefully, let's pick on, tell me your name in the back. Julia. Julia, can you graph f of x equals x squared?
Yeah.
It's a parabola. It's your satellite dish up on the top of your house so that you can watch. What do you like to watch? Sports, right? Yeah. Okay. All right. So now, what do you think the plus 3 is going to do to me? Is it going to move it over to the right, the left, up, or down? Move it up 3. Okay. So, and that's exactly right. Okay. It's going to be the exact same graph shifted up 3. So this works just for any function. Okay, so maybe I should start coming up with some rules. Okay. Are we only shifting? No, we're going to stretch and we're going to reflect. Okay, so I'm going to go a little differently than the book here because I think this is going to be a better way to teach you guys this. Okay, if I have f of x equals a, I want to do this. Times x minus b squared plus c. Okay? And maybe I won't put that, I'll put that to the nth power. Okay? So let's pretend that this represents a generic function, and this doesn't have to necessarily be x. But the idea here is if I have a plus c, it shifts it up c units. Okay? If I have a minus c, it shifts down c units. Okay? If I have a plus b, it shifts left b units. If I have a minus b, it shifts right b units. Then we get to the A. If it's a plus A and the minus A, actually there's two things to worry about with the A. Let's just worry about, let's assume that A is a whole number for now, okay? The plus A is going to keep your orientation, and your minus A is going to flip the orientation. Okay? And what I mean by that, I'm going to use an x squared for a moment, okay? We know that y equals x squared is in the positive direction, and if it's a negative, then it's just going to flip it in the negative direction. And this doesn't apply just to x squared, it applies to all functions, but I just want to use that for now, okay? Now, the question is, if A is a whole number versus if A is a fraction. Okay? And here's how I'm going to do this. I'm going to say that fractions are fatter. F and F. Fractions are fatter, and whole numbers are skinnier. Okay? And here's what I mean as applied to a parabola. Okay? So if I have a fraction, it's going to make it a fatter fraction. Or if I have a whole number, it's going to make it much skinnier. Does that make sense? Okay. So that's, I think, I'm trying to remember if there's any other options. Let me make sure I'm not missing anything. I think that's good. Okay, so I'll try to follow the book here.
Does the nth do anything? Does it make it like skinning or fatter?
Well,
Oh, that's okay.
no, the n is based on, the n is just kind of a generic function, which is hard to do, but oh, I guess I should. I think I got everything there. All right. So the question is, let's see how crazy, and we'll try to start with something easy here. So Aaron did one of these. So f of x equals x plus 4 quantity squared. Okay? Tell me your name. Hunter. So, do you know what that is a graph of, right? Just by looking at it? Parabola, right? Okay. Now the question is the parabola shifted up, down, left, or right? It shifted left. Okay. So if you're to draw this, we're going to go left. How many units? 4 units. 1, 1, 2, 3, 4. Okay? And does it open up or down? It opens up. Okay? So it's going to open just like that. Okay? So that was pretty easy. What if I did g of x? Uh-oh, my thing's dying. Left the lid off too long. Well, I guess we'll stick with the black. G of x equals x minus 2 squared plus 3. Hey, let's go crazy here. I haven't picked on you yet. What's your name?
Jonathan.
Jonathan? What do you think happened with that parabola?
You go up 3 on the left.
Up 3, 1, 2, 3.
And then go to the right.
To the right, 1, 2. That's where your vertex is. It's going to open up just like that, right? Okay. All right. What if? Okay. Now this works for all functions. So let's do. First of all, let's do f of x equals the square root of x. We're going to see if you remember all this. Who haven't I picked on? Mr. Parrish, I haven't picked on you. What's your name?
Christian.
Christian. What does that look like?
I'm just gonna go upside down. Is that, or no?
It's a what?
Is it just gonna be a parabola upside down?
It's not a parabola.
Okay.
It kind of looks like a half a parabola. I'll say that. But I see a lot of people doing this, and that's exactly right. It looks something like this, okay? Probably a little steep, okay? Okay? So now my question is, what if I asked you, I could have used the same color in my other colors. Maybe this will work. F of x equals the square root of x minus 2 plus 3. What's that do to it? So I don't think I picked on you yet. What's your name?
Spencer.
Spencer. So it's going to look like a square root function, right? It's just going to be shifted. How's it going to be shifted?
Properties are going to be similar to the other formula, right?
Correct.
So we're going to go up 3, and we're going to go to the right 2.
To the right 2. Okay. This is easy. This is a lot better than graphing point, or plotting points, right? Okay. How about well, this is a good one. What if I said g of x equals negative square root of x plus 3 minus 2? And let's just flip everything. Okay. Angel, it's been a long time since I picked on you. If it was. Okay. What do you think?
So first off, we know that minus 2 will bring it down to
Down 2.
the plus 3 will shift it left 3.
1, 2, 3.
Then assuming the negative in front means it's going to flip the orientation.
Okay.
So it should
Is it going to go up or is it going to go down?
come down.
It's going to go.
Actually, which axis would it flip on?
Yeah, it is going to flip it. It's going to flip it like that. Okay.
Isn't that over the origin though?
Let me make sure. No, you're right. It is. It's flipped over this way. How could I do that one? What would make it flip down like this? That would have to be a negative x. Just like that. Yes.
Wait, so what is the negative doing in front of it again? Like, how is that changing it?
Okay, so let's think about it this way. It might be easier just to take this function. You all know that's this piece right here, right? What if I graphed f of x equals minus square root of x? This is where I really wish I had more colors.
Okay, so
So if
Okay,
you put in a 1, it turns to -1, so it's got
so it's gonna go like this, right?
So you flip it over the y-axis?
F of x equals minus, square root of minus x. Am I doing that right?
Upside down, right?
All your x, oh, you know what? I did that wrong. It flips it like this.
Yeah, it's okay.
This one is here, this one is up here. That's what it is.
So how did you flip the red one over the over the origin?
Okay, so what he's saying,
Because I added the negative in both spots.
In both? Oh, yeah, yeah.
Yeah, that, so with the red, that is that one there.
Okay.
wouldn't it be, you have negatives on both?
Wouldn't
Or
it
you have
be-
Or
positives?
didn't your rules say like if you change A, then it flips it upside down?
Yeah, this is why it's hard when it's easy to do with a parabola, but sometimes it gets a little bit harder when you're doing with these. I've got so much here, let's do that again, okay? F of x, this is what, I should have brought another marker to that. F of x equals the square root of x. Everybody agrees with that, right?
Yeah.
Okay? What is, here, we'll try to use this, f of minus x. Which way does it flip it? Over the x or over the y?
Over the line.
Okay? So f of negative x equals square root of negative x, right? Okay? Let's talk about your domain for a second. In this red function here, what's your domain? X's all have to be less than or equal to 0, correct? So that means I can only use values on this side. Okay? So that 4, it's going to go this way. Over the y. It's going to flip over the y. Okay? Now, the next question is, hopefully my blue has had a chance to a little better. What's f of minus f of x? It's going to be minus square root of x, correct? Where does it flip? It's going to flip down here. Okay? And then finally, I really wish I had another color. We'll go with the black again, I guess. Minus f of minus x. It's going to be minus square root of minus x, right? Where's that going to be? It's going to be right here. Okay? So I know this, that's why this is really supposed to represent some sort of a function. I should probably have left that there. Okay? I gave you some examples with parabolas because those are easy to see. Some of these other functions are a little bit harder to see. Let me try. Okay, here's a good one. What if I have a graph that looks like this? Okay, I'm not going to give you any values. I'm just going to say this represents f of x. Okay? What would f of some number, say c times x equal? Is that going to make it wider or skinnier? So we vote. It's going to make it skinnier. So let's say let's pretend that c equals 2. Everything's going to shrink. It's going to be like that. Okay? Does that make sense? All right. If it was
Assuming C was a whole number.
f, yes, assuming c is a whole number. What if it's 1 over c times x? Now it's a fraction. Now it's going to be out here like this. Okay, assuming c is a whole number. Does that make sense? All right, I'm losing a lot of people, I can tell. We're almost done. The last thing I want to talk about is odd and even functions. All right. A function is considered odd if f of minus x equals minus f of x. A function is even if f of x equals f of minus x. Okay? Can almost guarantee that this will be on the final exam. Okay? So let's say, we'll try to do a couple of easy ones first. F of x equals x squared. Now, if you were to guess without doing anything, Niels, what would you guess?
What's your question?
Odd, even, or neither? Maybe multiple choice here.
For f of x equals x squared.
F of x equals x squared. Is that an odd, an even, or neither function?
If I had to guess, I'd say neither.
I'd guess even. I heard somebody else say even. Why did you say even?
Because anytime you square a negative number, it's going to equal.
Because that's an even number, right? F of x equals x to the fourth. Niels, what do you think that one is? Probably even. F of x equals x cubed. What do you think that one is? Odd. Okay. Those are all correct. Why did you guess that? Because it's an odd number, right? Okay. Now, those are correct answers, but that's not enough work to get the answer correct on the test. I want you to prove, so here's what I'm going to say. We're going to prove that this is an even function. Okay? Now, according to the definition, a function is even if f of x, I've already got f of x, right? That's already given to you, equals f of minus x. So let's figure out what is f of minus x if that's your function. Can you tell me, Niels?
Plugging in it.
So if I plug in a negative x right here, I'm going to get
It's going to be -4
negative x squared. Okay? When I simplify that, it becomes
x
x squared. Okay? So the essential thing says, okay, if I have a function and if I stick in a negative x, if I get the function back, it is even. Did I get my function back?
Yeah.
Yes. So therefore, it is even. Okay? Now, let's prove it again. This time, let's do, we want to prove f of x equals x cubed. I'll do it this way. Prove f of x equals x cubed is an odd function. Okay? Berkeley, let's do your turn. So if it's an odd function, what are the two things I need to find? So if I'm proving that it's odd, I need to find f of minus x, and I need to find f minus f of x. Okay? Once I complete those, if those equal each other, then it's odd. Okay? So what is f of minus x if this is my function?
Could be negative x.
Negative x to the third power. Okay, can I simplify that? Yes.
Take out the negative.
What's negative 1 to the third power?
Negative one.
It's negative 1. So that equals negative 1. And what's x to the third power?
Negative x.
So x cubed. So f of minus x equals minus x cubed, right? Okay. What's a minus f of x? Let's pick on Dino. I don't think I picked on you today. What's minus f of x if this is my function?
The x would be outside the points. So it'd be negative.
Negative
X.
x cubed, right? So that equals negative x cubed. Are those the same? Is this function odd? Okay. So yes, we've proven, we found f of minus x, we found minus f of x. We've proven that those are equal, therefore it is odd. Okay? Now let's do f of x equals x minus 2 squared plus 3. Is it odd, even, or neither? Okay? What'd you say? Oh, you can't see. Thank you. That's why we put that on there, so you can see. Okay? All right. How have I picked on? Oh, I haven't picked on you in the red. How could I miss you? Get a nice Utah shirt on, right? Tell me your name again.
Kelly. Sorry.
Kelly.
I'm sick right now.
Oh, except for it's not a Utah shirt. It says pink.
No.
It's red. It's a red shirt that says pink. That's wrong. It should say Utah. All right. So, what would be your guess if you were going to guess?
I would say
You would probably guess even first because we got an even number there, right? Okay. In order for it to be even, we have to prove that this is true. Okay. I've already given you f of x. What's the next thing I need to find? So now I need to find f of negative x. Okay? So what would be f of negative x in this case?
parentheses negative x minus 2 and then squared.
Plus 3. Okay, so my question to you is, are those the same?
Yes. No matter what, it's negative or positive, or positive plus 3.
Okay, so let's prove it. Okay? Prove it. If you were to FOIL this out here, this x minus 2 squared becomes x squared outside. Negative 2 times x is?
Sorry.
What's negative 2 times x?
Turns out it's negative 2.
Negative 2x, double that. Negative 4x. What's negative 2 squared? Positive 4.
I'm sorry.
Okay? Plus 3. So if I FOIL this out, this becomes x squared minus 4x plus 7. Do you agree with that? Okay? And since you have such a booming voice, I'm going to pick on someone else like, oh, I haven't picked on you. Oh, no, I have. I'm going to pick on you again. It's, I already forgot. Caitlin. Okay? So can you FOIL this out? Negative x times negative x is?
Is positive x squared.
Positive x squared. Negative x times negative 2.
Is 2x.
Positive 2x, double that.
Double that.
Yeah, we're foiling it.
Oh, so it's 4x squared?
Plus 4x, okay? Negative 2 squared is?
Negative 2 squared is positive 4.
Plus 4, plus 3. Okay, so when I simplify this, this becomes x squared plus a 4x plus a 7, right? Are those the same? No, I've got a problem here because those don't match. Okay? So therefore, at this point, I'm going to say it's not odd.
Even.
Not even, sorry. Not even. That's what I meant. Okay? So now, let's see if it's odd. In order to disprove that it's odd, okay, I need to find f of minus x, which I just have done. And I need to find minus f of x. What is minus f of x? I think we picked on just about everybody. Oh, Harvard, I forgot about you. I think I let you off the hook earlier. It's
Nate.
Nate. Okay. What's minus f of x if this is your f of x here?
It'd be minus.
Minus times the whole thing, right? Minus the whole thing, which is
X minus 2 squared, parentheses squared plus 3.
okay. So let's simplify that. I'm going to go over here though. Okay. So let me erase all this stuff. Okay, so the inside of this we know is what, or do you know? Here, I'm just going to rewrite what I wrote there. So minus f of x equals minus x minus 2 squared plus 3. Okay? Do you want to FOIL it out first? Yes?
Can we just take the first one, the f of x, and multiply everything by a negative?
That's what I want to make sure. You can do it if you do it the right way. But I'm scared if some of you won't do it the right way. So we're going to try to be slow and make sure we do this slow. You guys are always going to complain we're going too fast anyway, right? Okay? So let's FOIL that. If we FOIL that out, you're going to get, Nate, what?
X squared
Oops, I erased it.
minus 4x.
X squared minus 4x
Minus 4.
plus 4 plus 3, right?
Yeah.
So that's really going to become plus 7. And I'm going to multiply that by a negative, right? So therefore, this becomes negative x squared plus 4x minus 7. And that's minus f of x, okay? Now, in order for this to be odd, that has to equal f of minus x. Okay, now from over here, we had f of minus x was this one right here. X squared plus 4x plus 7. X squared plus 4x plus 7. Are those the same? So therefore, it's not odd. Okay? If it's not odd and it's not even, it is neither.
Can it be both?
Can it be both? No. Okay, and when we're talking about even functions and odd functions, okay? So another way to think about this is with the vertical line test, right? This is y equals x cubed. Is that odd or even? Odd. It's odd, okay? It's a function, right? It's a function because of the vertical line test. If I do y equals x squared, is that odd or even? It's even. I can do a vertical line test that says that it is a function, okay? Now there is one case. Another way to think about this, a function is even if it is symmetric about the y-axis. An odd function is odd if it's symmetric about the x-axis. That's another definition which I didn't get to, okay? Now, there is a function called a circle. I stated that wrong. A circle, is it symmetric about the x? Yes. So symmetric about the x would say it's odd. Is it symmetric about the y? Yes. Symmetric about the y would also say that it's even, right? But is it a function? It's not a function because of the vertical line test, okay? So, yeah, that's probably another important definition. You should be able to look at a function. That's odd. Is this, how about this one? Is that an odd, an even, or a neither function? It's neither because it's neither symmetric about the y nor the x, okay? So shifted functions are usually not, well, it depends on how they're shifted. Would this function, if this is a cubic function, is that odd? No, because it's not, let me think about that.
It's not symmetric about the x.
It's not symmetric about the y-axis, right? Yeah. So shifted functions usually are neither odd nor even. I'll put it that way. But I'm going to emphasize the usually, not the always. Okay? All right, we're out of time. Quiz tomorrow is on 2.4 and 2.6. I'm sorry I gave you all that extra homework, but you're going to appreciate it on the test when you ace my test. Okay? See you all tomorrow.
So the chapter, or the edition 6 book, is it the same problems in edition 7? Is that what you mean by like do? Yeah.
Whatever I have in your 6th edition, just do them anyway.
Yeah.
They're going to be close enough.
I have the 7th edition.
Yeah, that's what I have too.
Oh, okay, so just do the one that's saying in the 6th and 7th.
Right.
Alright.
Wait, sorry, I didn't get that. So the 6th edition practice